Nature is full of surprises, from glowing oceans and colour-changing rivers to thunderous storms and mysterious lights in the sky. Around every corner, Earth and its atmosphere create wonders that feel almost magical. In this script, we'll uncover 100 fascinating facts about natural phenomena that shape our world. Prepare to explore the hidden, the strange, and the breathtaking side of our planet like never before. Fact 1. How earthquakes occur beneath Earth's crust. Imagine standing on solid ground, feeling the earth steady beneath your feet, and then, without warning, it moves. It rumbles, trembles, sometimes even cracks open. That's an earthquake, a sudden reminder that what seems unshakable isn't quite so still after all. Beneath us, the Earth's crust isn't one continuous layer. It's a giant jigsaw puzzle of plates, massive slabs of rock floating on a softer molten layer called the mantle. These plates are always moving, but we can't feel their slow crawl. They drift only a few centimeters each year like fingernails growing, yet when they grind, collide, or slide past each other, energy builds up at their edges. Think of it like stretching a rubber band. Tension grows quietly until snap. It releases all at once. In an earthquake, the snap happens deep underground, often kilometers below the surface, along cracks called faults. When that built-up pressure finally gives way, it sends waves of energy racing outward. That shaking we feel is the surface's reaction to what's happening far below. Some quakes are so small they pass unnoticed. Others can shake entire cities, bending steel and toppling buildings. But here's the surprising part. Most of the time, the Earth is releasing pressure slowly, harmlessly. It's those rare, sudden breaks that cause the chaos. Scientists use seismographs to measure these movements, tracing how the waves travel. By studying their speed and direction, they can tell where the quake started, the epicenter, and how deep the rupture was. Every tremor adds another clue to Earth's restless story. Earthquakes remind us that the planet is alive in its own way, not breathing like we do, but shifting, stretching, and reshaping itself endlessly. That quiet ground beneath our feet, it's never truly still. Fact 2. The hidden world of tectonic plate boundaries. Deep beneath the oceans and continents lies one of Earth's most secretive systems, the boundaries between tectonic plates. You can't see them, but they're the reason our planet has mountains, trenches, volcanoes, and earthquakes. They're where continents drift apart, where oceans are born, and where land masses collide like slow-motion giants. There are 3 main kinds of plate boundaries. At divergent boundaries, plates pull away from each other, creating rifts where molten rock seeps up to form new crust. This is happening right now along the Mid-Atlantic Ridge, a hidden mountain range running under the ocean, wider than you might imagine. Then there are convergent boundaries, where plates push toward one another. One plate usually slides beneath the other, sinking into the mantle. This process, called subduction, forms deep ocean trenches and fiery volcano chains, but we'll come back to that later. Finally, there are transform boundaries, where plates slide sideways past each other. The famous San Andreas Fault in California is one example. When these plates get stuck, pressure builds up until it releases violently. That's when earthquakes strike. What's fascinating is that these boundaries don't just shape landscapes, they control much of Earth's behavior. Ocean currents, mountain formation, even climate patterns are tied to their slow movements. It's like the planet's heartbeat, steady, unstoppable, always changing the face of the world. We walk on continents that seem permanent, but in geological time they're just travelers, drifting, colliding, and breaking apart again. That's the hidden world beneath us, restless, powerful, and endlessly creative. Fact 3. Why volcanoes form near subduction zones. If you've ever watched footage of a volcano erupting, you've seen raw power, rivers of lava, clouds of ash, and a sky that glows red. It's dramatic and terrifying. But why do so many volcanoes appear in the same places, especially around the edges of oceans? The answer lies deep below, where tectonic plates meet in what's known as a subduction zone. Picture 2 plates colliding. One is heavier, usually an oceanic plate, and the other lighter, like a continental plate. When they crash, the heavier one gets forced down beneath the lighter one, sinking slowly into the mantle. As it descends, the pressure and heat increase until the sinking rock starts to melt. That molten material, called magma, is less dense than the solid rock around it, so it rises. Eventually the magma reaches the surface, bursting through cracks and forming a volcano. Over time, repeated eruptions build entire mountain ranges, like the Andes in South America or the Cascades in North America. These fiery lines circling the Pacific Ocean form what scientists call the Ring of Fire, a chain of volcanoes born from subduction zones. What's incredible is that every eruption, every plume of ash, is part of Earth recycling itself. Old crust disappears into the mantle, melts, and returns to the surface in a new form. It's destructive and creative all at once, the planet's way of breathing, renewing, and transforming over ages. So the next time you see a volcano on the news, remember, it's not random. It's part of an ancient rhythm, the deep, slow pulse of a planet that never truly rests. Fact 4. The science behind volcanic lightning. Volcanic lightning sounds like something out of a fantasy story, glowing bolts flashing through clouds of ash. But it's very real, and one of nature's most electrifying spectacles. When a volcano erupts, it sends a huge column of ash, rock and gas high into the sky. Inside that dense, swirling cloud, tiny particles are constantly colliding. Every collision knocks off electrons, creating static electricity. The same thing that happens when you rub a balloon on your hair, just on a massive scale. As the charged particles separate, with positive charges rising and negative charges sinking, tension builds. Eventually, that tension has to discharge, and when it does, lightning crackles through the volcanic cloud. It can look wild, forked bolts lighting up ash plumes, flashes illuminating the darkness. Some eruptions are so powerful they create their own weather, thunder, wind, even rain. Scientists call this a dirty thunderstorm. It's chaotic, unpredictable, and almost impossible to study up close. Cameras and instruments placed miles away have caught these lightning storms in detail, but each eruption is different, shaped by ash type, humidity, and eruption speed. Despite the danger, these lightning storms are oddly beautiful. They remind us that energy is everywhere, even in destruction. It's the same principle behind thunderclouds, only multiplied by volcanic fury. In a strange way, volcanic lightning shows how connected everything is. Rock, air, fire, and electricity, all part of one breathtaking performance written by the Earth itself. Fact 5. How geysers, like Old Faithful, work. If you've ever stood near a geyser moments before it erupts, you know the tension that builds. The ground trembles slightly, steam hisses, and then, in a sudden burst, boiling water shoots high into the air. It's dramatic, rhythmic, and almost alive. Geysers like Old Faithful in Yellowstone National Park are nature's pressure cookers. Deep underground, water seeps into cracks and pockets near hot volcanic rocks. That heat turns the water into steam, but it's trapped by cooler water above it, building immense pressure. When the pressure finally overcomes the weight of the cooler water, the geyser erupts. The superheated steam blasts upward, carrying water with it in a spectacular jet that can reach tens of meters high. After the eruption, the chamber refills, reheats, and the process begins again, a natural cycle that can take minutes or hours depending on the geyser. What makes Old Faithful so famous is its consistency. While most geysers are unpredictable, this one erupts roughly every hour and a half, like clockwork. It's been doing this for centuries, its underground system remarkably stable. But geysers are fragile. Even a small change, an earthquake shifting the rock layers or a drop in the water table, can silence them forever. They're rare because the conditions that create them are so specific: heat, water, and just the right kind of plumbing beneath the surface. Watching one erupt feels like witnessing the earth breathe, a slow, powerful exhale from deep within. In that moment, you can almost hear the planet whisper, "There's more life down here than you think." Fact 6. The mystery of underwater volcanoes. Imagine standing at the edge of the ocean, looking out over a calm blue surface. It feels peaceful, endless, quiet. But beneath that calm lies a world of chaos, a realm where fire and water meet in the most unexpected ways. This is the hidden world of underwater volcanoes. Most people picture volcanoes as mountains that rise above the land, spewing lava into the air. But here's the twist. More than 3/4 of all volcanic activity on Earth happens underwater. Thousands of volcanoes line the ocean floor, stretching like scars along vast cracks called mid-ocean ridges. Down there it's dark, cold, and under crushing pressure. Yet molten rock from deep inside the earth still finds its way up through the cracks. When it reaches seawater, it cools almost instantly, forming strange, rounded structures called pillow lavas, smooth and bulbous like stacks of melted glass. These volcanoes don't always explode the way surface ones do. Sometimes they ooze quietly, building new seafloor bit by bit, but others can erupt violently enough to send plumes of ash and pumice floating to the surface. Entire new islands can rise this way, only to vanish back beneath the waves when the eruption stops. Scientists use remote submarines and sensors to study these hidden giants. What they've found is astonishing. Around these volcanic vents, life thrives. Tube worms, giant clams, and bacteria survive without sunlight, feeding on minerals spewing from the Earth's depths. These ecosystems could hold clues to how life began on our planet, and maybe how it could exist on others. So, the next time you stare at the ocean, remember, it's not just water hiding below. It's a living, breathing world of fire, creation, and mystery. Fact 7. The process of mountain formation. Mountains look timeless. Massive, silent guardians of the horizon. But every ridge, every peak has a story of struggle written in stone. They are born not from stillness, but from unimaginable pressure and movement beneath the surface. The process begins deep within the earth, where tectonic plates drift slowly across the mantle. When two of these plates collide, something incredible happens. The edges of the crust crumple and fold, like a rug pushed from both ends. Over millions of years, those folds rise higher and higher, forming towering mountain ranges. The Himalayas, for instance, are still growing. They began forming when the Indian plate slammed into the Eurasian plate roughly 50 million years ago, and that collision hasn't stopped. The land still rises a few millimeters each year, so the mountains you see today are taller than they were even in your grandparents' time. But not all mountains come from collision. Some form when molten rock pushes upward, creating dome-like shapes. Others rise along faults where the crust stretches and breaks apart. The result is always the same, nature reshaping its own face. When you look at a mountain, you're seeing time itself made visible. Layers of rock that once lay flat at the bottom of an ancient sea, now standing miles above. It's proof that Earth never stands still, and if you ever stand on a mountaintop with wind rushing past and the world stretched out below, remember this: you're standing on something that took millions of years to rise, and it's still moving, even now. Fact 8. How tsunamis gain a destructive power. Tsunamis are one of nature's most deceptive forces. They often begin quietly, deep below the ocean, with barely a ripple on the surface. Yet within hours, they can become walls of water capable of reshaping entire coastlines. It usually starts with an underwater earthquake. When a tectonic plate suddenly shifts, it pushes or pulls a massive column of water. Unlike normal waves, which are formed by wind and affect only the surface, a tsunami involves the whole ocean from top to bottom. The energy spreads outward in all directions, moving faster than a jet plane, sometimes over 800 kilometers an hour. Out in the deep sea, a tsunami may rise only a few centimeters high, completely invisible to passing ships. But as it approaches shallow coastal waters, the story changes. The wave slows down, and all that energy has nowhere to go but up. It compresses, stacking water higher and higher until it towers over the shore. When it hits land, the first wave isn't always the largest. Sometimes the second or third brings the most destruction. The water rushes inland, carrying debris, dragging everything in its path, then retreats, only to surge back again. Scientists now use ocean buoys and satellites to track these waves, giving coastal communities precious minutes to evacuate. But despite technology, tsunamis remain unpredictable in their scale and timing. They remind us how much power still lies hidden beneath the sea, and how a single shift beneath the crust can send ripples that reach halfway across the world. Fact 9. What causes sinkholes to appear? Suddenly. You're driving down a familiar road or walking through a park you've known for years, and suddenly the ground gives way. A hole opens up, swallowing everything above it. It's sudden, frightening, and it seems impossible. Yet sinkholes are very real, and they can appear almost without warning. At first glance, the surface looks solid, but beneath, the Earth can be hollowing out quietly for years. In many regions, especially those with limestone, gypsum or salt beneath the soil, water slowly dissolves the rock. Rainwater, slightly acidic, seeps through cracks, carving out underground cavities over time. As the cavities grow, the surface loses support. All it takes is one heavy rain, a burst pipe, or a vibration from traffic, and the ceiling collapses. That's when a sinkhole opens up, sometimes small, sometimes large enough to swallow entire buildings. Florida, parts of China, and the Middle East are especially prone to them, but they can happen anywhere the conditions are right. Even human activity, drilling, construction, or groundwater pumping, can trigger collapse by disturbing the fragile balance underground. It's unsettling to think about, but also fascinating. Beneath even the calmest landscapes, the Earth is constantly reshaping itself. Most sinkholes eventually stabilize, forming ponds or natural wells, reminders that the ground beneath us is always in motion, even when we can't see it. Fact 10. The phenomenon of soil liquefaction. During quakes. During a powerful earthquake, you might imagine solid ground cracking or shifting. But what if the ground itself started behaving like a liquid? That's exactly what happens during soil liquefaction, one of the strangest and most destructive earthquake effects. It occurs in loose, water-saturated soils, the kind often found near rivers, beaches, or reclaimed land. Under normal conditions, soil particles are packed together, and the water between them helps carry weight. But when an earthquake strikes, the shaking increases the pressure in that water. Suddenly the soil loses its strength. It can't support buildings, roads, or anything resting on it. Structures start tilting, sinking, or collapsing as if they were standing on quicksand. In some cases, buried pipes and tanks even float to the surface. One of the most famous examples happened in 1964 in Niigata, Japan. Entire apartment blocks sank into the ground, tipping over in eerie slow motion, not from the shaking itself, but because the soil beneath them had turned to liquid. Engineers now study liquefaction carefully when designing buildings in quake-prone areas. By improving drainage or compacting the soil, they can reduce the risk. But nature still finds ways to surprise us. Liquefaction shows just how fragile the line is between solid and fluid. The Earth we stand on feels firm, dependable, until it isn't. And when it moves, it reminds us that even the ground beneath our feet can change in an instant. Fact 11. The formation of thunderstorms. It usually starts quietly, a warm afternoon, humid air hanging heavy over the ground. Then the sky darkens. You feel that change in the air, a cool breeze brushing your skin, and suddenly, thunder rolls in the distance. That's the birth of a thunderstorm, nature's most dramatic mood swing. Thunderstorms form when warm, moist air rises from the ground into cooler layers of the atmosphere. As the air climbs, it cools and the moisture condenses into tiny droplets, forming towering clouds called cumulonimbus. These clouds can reach incredible heights, sometimes over 12 kilometers tall like mountains made of vapor. Inside these clouds, chaos brews. Updrafts push warm air upward, while downdrafts pull cool air down. Droplets collide, grow and freeze, building layers of ice that clash violently in the turbulent air. With every collision, electric charges separate. Positive charges move to the top of the cloud, and negative ones gather near the bottom. The stage is set for lightning, thunder, and heavy rain. A fully developed thunderstorm is like a living engine, powered by heat and moisture. It breathes in warm air and exhales rain, wind, and flashes of light. But storms don't last forever. Once the supply of warm air is cut off, the storm begins to collapse. Rain cools the lower atmosphere, weakening the updrafts that feed it. Still, the drama it leaves behind, the smell of wet earth, the rumble that fades into silence, feels like nature exhaling after a long sigh. A thunderstorm is a perfect balance of creation and release, a reminder that even chaos has rhythm. Fact 12. How lightning chooses where to strike. Lightning doesn't think, but if you've ever watched a storm, it feels almost intentional. Bolts zigzagging across the sky, one hitting a tree, another a tower, and sometimes even open ground. So how does lightning decide where to strike? The truth lies in electricity's one simple rule: it always takes the easiest path. When thunderclouds charge up, they create a massive imbalance between the cloud and the ground. The lower part of the cloud fills with negative charges, while the ground beneath it becomes positively charged. Nature hates imbalance, so it tries to fix it, and the result is lightning. Before the strike, invisible leaders of electricity branch downward from the cloud, reaching toward the ground in quick flickering paths. At the same time, upward streamers of positive charge leap from tall objects, trees, buildings, even blades of grass. When one of those upward streamers connects with a downward leader, a brilliant bolt flashes, releasing the built-up charge in a fraction of a second. That's why tall or pointed objects are more likely to be struck. They shorten the distance between cloud and ground. But sometimes lightning travels sideways through the air or strikes miles away from the main storm. These bolts from the blue are rare but powerful reminders that lightning doesn't always follow expectations. In the end, lightning doesn't choose, it follows physics. And that crack of light you see across the sky, it's just nature's way of restoring balance, quick, blinding, and unforgettable. Fact 13. Why thunder follows lightning. It's one of nature's most familiar patterns. First, a flash of light. Then a few seconds later, a deep rolling boom. Lightning and thunder always come as a pair, but they don't arrive at the same time. So why does thunder lag behind? When lightning strikes, it heats the air around it to incredible temperatures, up to 5 times hotter than the surface of the sun. That sudden burst of heat makes the air expand almost instantly, creating a powerful shock wave. That wave travels outward as sound, and that's thunder. Light, however, moves much faster than sound, almost 1,000,000 times faster. So we see the lightning instantly, while the thunder takes its time reaching us. That delay is what allows people to count the seconds between flash and rumble to estimate how far away the strike was. Roughly 3 seconds between them means the lightning hit about 1 kilometer away. But thunder isn't just one sound. It rolls, rumbles, and sometimes cracks sharply because of the landscape and the shape of the storm. The sound waves bounce off clouds, buildings, and hills, stretching that single burst into a long, echoing roar. Next time you hear thunder, think of it as lightning's voice, delayed but powerful. It's the sound of air being ripped apart and rushing back together, a reminder that even light leaves a lasting echo. Fact 14. The science behind hailstones. Picture a summer storm, dark clouds swirling overhead, and suddenly, ice begins pelting the ground. Not snow, not sleet, but solid chunks of ice falling from a warm sky. That's hail, one of weather's strangest tricks. Hailstones are born high inside thunderclouds. In these massive storm towers, updrafts of warm air shoot upward with tremendous force, sometimes over 100 kilometers an hour. Water droplets get caught in those updrafts and carried into regions so cold that they freeze. Once frozen, the small ice pellets begin to fall, but the updraft pushes them up again, adding another layer of water that freezes around the core. This cycle repeats over and over, up, down, up again, until the hailstone grows too heavy for the air to support. Then it falls to the ground, sometimes as small as a pea, sometimes as big as a baseball. The size of hail depends on the storm's strength. The more powerful the updraft, the larger the stones. That's why hail often accompanies severe thunderstorms, or even tornado-producing storms. Each hailstone carries a record of its journey. When sliced open, you can see rings inside it, like the growth rings of a tree. Every ring marks a trip through the freezing layers of the cloud. It's strange to think that something so solid and cold could come from the heart of a storm filled with heat and motion. But that's hail, a reminder that opposites often work together to create something extraordinary. Fact 15. How tornadoes form and rotate. A calm afternoon can turn terrifying in minutes. The air grows still, the clouds twist into eerie shapes, and suddenly a funnel drops from the sky spinning with violent force. That's a tornado, nature's most intense dance of wind and chaos. Tornadoes begin inside powerful thunderstorms, especially ones with strong wind shear. That's when winds at different heights blow in different directions or speeds. This creates invisible, horizontal tubes of spinning air in the atmosphere. When a thunderstorm's updraft tilts one of those spinning tubes upright, it becomes a rotating column of air within the storm, a mesocyclone. As the rotation tightens and strengthens, it starts pulling air in faster and faster. The tighter it spins, the stronger it becomes, much like an ice skater pulling in their arms to spin faster. If the rotation extends downward and touches the ground, a tornado is born. Inside, wind speeds can exceed 300 kilometers an hour, strong enough to lift cars or strip trees bare. Most tornadoes last only a few minutes, carving a narrow but devastating path. They're unpredictable, sometimes forming from calm skies, other times vanishing before anyone sees them. But meteorologists now track the early signs with radar, giving precious warnings to communities in their path. Despite their fury, tornadoes are part of the planet's natural energy balance, redistributing heat and moisture through the atmosphere. Terrifying, yes, but also a powerful reminder of how alive the air around us really is. Fact 16. What makes supercells so powerful? Ever looked up at a storm cloud that seemed to tower endlessly into the sky, with flashes of lightning pulsing inside it like a living thing? That's a supercell, the heavyweight champion of thunderstorms. Unlike ordinary storms, a supercell has one feature that makes it both fascinating and terrifying: a rotating updraft called a mesocyclone. It all starts with wind shear. That's when winds at different heights move in different directions or at different speeds. Imagine stirring a pot of soup but from opposite sides. The air begins to twist. When a strong updraft, warm air rising fast, catches that twist, it pulls the rotation upright. Now, the storm begins spinning vertically, like a spinning top that just woke up angry. Inside that rotation, chaos brews. Rising warm air keeps feeding the storm while cooler air sinks around it, forming a self-sustaining cycle. This balance between rising and falling air makes supercells last much longer than ordinary thunderstorms. While a regular storm might fizzle out in an hour, a supercell can keep roaring for several hours, sometimes even travelling hundreds of kilometres. But that's not all. Supercells can spawn the most violent tornadoes, unleash giant hailstones, and produce non-stop lightning. Meteorologists often call them the complete storm, because they can do everything nature can pack into one system. Still, there's something strangely majestic about them. From a distance, they look like enormous, sculpted towers reaching the edge of the atmosphere, nature's own masterpiece, though one best admired from far, far away. Fact 17. The difference between hurricanes, cyclones, and typhoons. Here's a little secret about some of the most feared storms on Earth. Hurricanes, cyclones, and typhoons are actually the same thing. Yes, you heard that right. The only real difference is where they form. If this swirling storm forms over the Atlantic Ocean or the northeastern Pacific, it's called a hurricane. In the northwestern Pacific, it becomes a typhoon. And if it spins up over the Indian Ocean or near Australia, it's a cyclone. Same phenomenon, different names. These storms all begin the same way. A warm ocean water, at least 26 Duros, heats the air above it. The warm, moist air rises, creating an area of low pressure below. Surrounding air rushes in to fill the gap, and because of Earth's rotation, the whole system starts spinning. That's the birth of a tropical cyclone, a rotating engine powered by ocean heat. As it grows, wind speeds increase, clouds thicken, and an eye forms at the centre, calm, quiet, but surrounded by walls of violent winds and rain. The moment this system moves over land, it starts to weaken, cut off from its energy source, the warm sea. So, hurricane, cyclone, or typhoon, it doesn't matter what name it wears. It's the same incredible, fearsome expression of nature's energy, shaped only by geography and language. Fact 18. How dust devils form in dry regions. If you've ever seen a small whirlwind spiralling across a hot, dusty plain, dancing like it has a mind of its own, that's a dust devil. It might look like a miniature tornado, but it's born from sunlight and heat, not storm clouds. Here's how it happens. When the sun heats the ground intensely, the air right above the surface warms up faster than the air above it. That warm air becomes lighter and starts to rise quickly. As it rises, cooler air from around it rushes in to take its place. If the incoming air starts spinning even slightly, the rising column of air turns into a swirling vortex. The result? A tall, twisting column of spinning air filled with dust, leaves, or sand. Most dust devils are harmless and short-lived, lasting just a few minutes, but under extreme heat some can grow several meters wide and spin fast enough to lift small objects. Unlike tornadoes, dust devils form under clear skies. They're a reminder that even without clouds, The atmosphere above us is constantly alive, restless, swirling, and waiting for the right mix of heat and motion to create a brief, beautiful spectacle. Fact 19. The phenomenon of ball lightning. Now, here's a mystery that has puzzled scientists for centuries. Ball lightning. People have described it as glowing orbs floating silently through the air during storms, sometimes drifting through windows or vanishing with a soft pop. It sounds like something out of folklore, yet thousands of reliable witnesses have seen it. Ball lightning usually appears during thunderstorms, often right after a lightning strike. But unlike regular lightning, which lasts a split second, these glowing spheres linger, hovering, rolling, or even moving against the wind. No one fully understands how they form. One theory suggests they're made of vaporized silicon from the soil, ignited by a lightning strike. Another proposes that microwaves trapped in a plasma bubble might explain their glow. Whatever the cause, ball lightning remains one of nature's strangest tricks. Scientists have even recreated similar phenomena in labs, but the real thing, the eerie floating lights that sometimes appear during storms, still holds an air of mystery. They remind us that even in an age of satellites and science, the sky still keeps a few secrets for itself. Fact 20. The strange behavior of fire whirls. Now imagine a tornado made of fire. That's not a fantasy. It's a fire whirl, sometimes called a fire tornado. It forms when intense heat from wildfires or explosions causes air to rise rapidly. If there's even a hint of a horizontal breeze, the rising air starts to rotate, forming a spinning column of flame. At first, it might look like a flicker of fire twisting in the wind. But as it grows, it can stretch dozens of meters high, spinning so fast that it sucks in burning debris and spreads flames farther. Some have even been strong enough to toss vehicles or uproot trees. Fire whirls don't last long, but they're incredibly dangerous. What makes them eerie is how alive they seem. Flickering, roaring, and moving unpredictably, as if the fire itself decided to dance. They're rare, but every firefighter knows that when conditions are just right, high heat, low humidity, and shifting winds, the ground can suddenly give birth to a tornado made entirely of flame. It's one of nature's most stunning yet terrifying reminders. Even fire can learn to spin. Fact 21. How rainbows are formed. There's something magical about seeing a rainbow after a storm. It's like nature's way of saying, calm down, it's over. But behind that beauty lies a simple bit of science. A rainbow begins with sunlight and raindrops. That's all it takes. When sunlight passes through a drop of rain, it bends, or refracts, as it enters the water. Then it reflects off the back of the droplet, and bends again as it exits. This bending and reflecting split the white sunlight into its individual colours: red, orange, yellow, green, blue, indigo, and violet, creating a beautiful arc across the sky. Each raindrop produces one colour, depending on the angle at which the light leaves it. But since millions of drops are falling at once, our eyes see all those colours arranged perfectly side by side. Red light bends the least, violet bends the most, and together they paint the sky with a smooth gradient of colour. Rainbows always appear opposite the sun. That's why you can't see one if you're facing it. And they're not really arcs in shape, they're full circles. We just can't see the lower half because the ground gets in the way. So the next time you spot a rainbow stretching across the horizon, remember, you're not just seeing colour, you're seeing sunlight taking a detour through tiny raindrops, bending and bouncing in a million directions, only to end up right where you can see it. Fact 22. The secret of double rainbows. Every once in a while, nature decides that one rainbow just isn't enough, and we get two. Double rainbows feel almost unreal, like the sky's showing off. But there's a simple reason behind the extra arch. When sunlight enters a raindrop, part of it reflects once inside the drop. That's the main rainbow we usually see. But some of that light bounces twice before leaving, and that second reflection creates another fainter rainbow above the first one. Here's the interesting part. Because of that extra reflection, the order of the colours in the second rainbow is reversed. Red is now on the inside, violet on the outside, and since it reflects twice, it's also dimmer, often just barely visible compared to the bright primary arc below. Between the two rainbows, you might notice a darker area of sky called Alexander's Band. Named after the ancient philosopher who first described it nearly 2,000 years ago, it's a subtle, shadowy region caused by how light is dispersed between the two arcs. So when you see a double rainbow, you're really witnessing sunlight bouncing twice inside millions of raindrops, painting two perfect arcs in the air. It's one of those rare moments when the sky decides to double its beauty. Fact 23. What causes halos? Around the moon or sun, have you ever looked up on a cold night and seen a glowing ring circling the moon? Or maybe you've seen one around the sun on a frosty morning. Those glowing rings are called halos, and they're made not by rain, but by ice. High up in the atmosphere, far above where clouds drift lazily, tiny hexagonal ice crystals float in thin cirrus clouds. When light from the moon or sun passes through these crystals, it bends at a precise angle, usually 22 degrees, and spreads out in a circle of pale light. That's the halo you see. The shape of the ice crystals determines the kind of halo that appears. Flat crystals create the perfect ring, while column-like ones can form arcs, pillars, or even rare double halos. When you see one, it often means that a weather front is approaching. Those ice crystals are the first signs of a larger system moving in. The next time you spot that delicate white ring around the moon, take a moment. You're not just seeing light, you're seeing the signature of countless tiny crystals high above the world, each bending moonlight just enough to make the night sky shimmer. Fact 24. The green flash at sunset. You know that quick, almost magical moment when the sun dips below the horizon and the world glows gold. If you're lucky, and paying attention, you might catch something even rarer, a green flash. It lasts only a second or two, but people who've seen it never forget it. Just as the sun disappears, a sudden burst of emerald light appears on the upper edge of the disk. The reason? It's all about light refraction. As the sun sets, its light passes through more of Earth's atmosphere than at any other time. The atmosphere bends, or refracts, different colours of light by different amounts. Blue and green light bend more than red and orange. But since blue light is scattered out of view by the atmosphere, we're left with the green, a brilliant, fleeting spark right before the sun vanishes. You need a clear horizon and clean air to see it, often over the ocean or desert. And though it seems almost mystical, it's just sunlight being stretched, bent and filtered in one final show before nightfall. The green flash is nature's brief encore, a quick wink from the setting sun to remind us to keep watching. Fact 25. The aurora borealis and australis. If you've ever seen the night sky come alive with curtains of green, purple or red light, you've witnessed one of Earth's most mesmerizing displays, the aurora. In the northern hemisphere, it's called the aurora borealis. In the southern hemisphere, aurora australis. It all begins with the sun. Solar flares and coronal mass ejections release streams of charged particles that travel through space and eventually reach Earth. When they collide with Earth's magnetic field, they're guided toward the poles. That's why auroras appear in polar regions. As these charged particles hit molecules in the upper atmosphere, they excite the gases there, causing them to glow. Oxygen produces green and red hues, while nitrogen adds blue and purple tones. The result is a constantly shifting curtain of colour that ripples across the sky. Each display is different, sometimes faint and ghostly, other times so bright that they light up the snow-covered ground like day. There's something deeply humbling about standing beneath an aurora. You're watching the invisible dance between the sun and earth, made visible through light. It's one of the few natural wonders that feels alive, whispering, glowing, and moving in ways that no photograph can truly capture. Fact 26. Mirages in the desert. You've probably seen it in movies. Travellers stumbling through a shimmering desert, chasing what looks like a lake of water that vanishes the closer they get. That illusion isn't just a trick of the mind, it's a real optical phenomenon called a mirage. A mirage forms when light bends as it passes through layers of air with different temperatures. In the desert, the ground becomes scorching hot under the sun, heating the air just above it. Higher up, the air remains cooler. When light from the sky moves through these layers, it bends upward before reaching your eyes. Your brain, always trying to make sense of things, assumes the light came straight from the ground. So it creates an image of the sky on the surface, which looks like a shimmering pool of water. Mirages aren't limited to deserts either. You can see them on hot roads, where distant cars or trees appear to float above the pavement. It's light bending, not the earth melting, but it sure looks that way when heat and light start to play tricks together. Fact 27. The glory phenomenon seen from airplanes. If you've ever looked out of an airplane window and seen a circular rainbow surrounding the plane's shadow on the clouds below, you've witnessed something called a glory. Unlike a typical rainbow, which forms from refraction, a glory is created when sunlight is scattered backward by tiny water droplets. The light waves bend, reflect, and interfere in such a way that they form colourful concentric rings, like a halo, around the shadow of the plane. Pilots call it the pilot's halo, and hikers sometimes see it too when standing on mountain peaks with clouds beneath them. The beauty of a glory is its intimacy. It feels personal, because the circle always surrounds the observer's own shadow. It's one of those quiet moments that reminds you how sunlight, water, and perspective can work together to create art, fleeting and perfect. Fact 28. The Brocken spectre on mountaintops. Climbers who reach fog-covered peaks sometimes witness something that feels otherworldly, a giant shadow figure surrounded by rings of light. This is the Brocken spectre, named after a mountain in Germany where it's often seen. Here's what really happens. When the sun is behind you and you're facing mist or fog below, your shadow is cast onto the fog bank. Because the water droplets in the mist scatter light backward, your shadow appears enormous and ringed by coloured halos. Move your arm, and the shadow moves too, larger than life, stretching across the clouds. In the past, travellers were frightened by it, thinking they'd seen a spirit or ghostly figure. But it's just sunlight, mist, and perspective combining in the perfect alignment. If you ever find yourself high above the clouds with the sun at your back, watch carefully. The mountain might just show you your own illuminated reflection. Fact 29. Why skies appear blue and sunsets. Red. Every time you look up, you're witnessing a simple trick of physics painted across the entire sky. The reason the sky appears blue, and sunsets red, comes down to how sunlight interacts with the atmosphere. Sunlight is made up of many colours, each with different wavelengths. When sunlight enters the atmosphere, molecules of air scatter shorter wavelengths, like blue and violet, more than longer ones, like red and orange. Our eyes aren't very sensitive to violet, so we see the sky as blue. At sunrise and sunset, the sun's light travels through a thicker layer of atmosphere. The blue light scatters out of view, leaving the longer red and orange wavelengths to dominate. That's why sunsets glow warm and skies turn golden. So when the world shifts from blue to orange to pink, you're not just seeing colour, you're watching sunlight travel through air, changing hues as it stretches across the horizon. Fact 30. The optical illusion of Fata Morgana. The name Fata Morgana sounds like something from a legend, and fittingly it was named after the sorceress Morgan Le Fay of Arthurian tales. But the phenomenon itself is very real, and it's one of the most complex mirages in nature. A Fata Morgana happens when layers of air with sharply different temperatures stack above one another, creating multiple bends in the path of light. The result is an image that can appear stretched, flipped, or stacked, sometimes making ships look like they're floating in the air or cities shimmer above the sea. Unlike simple desert mirages, a Fata Morgana can show incredibly detailed illusions that shift rapidly as the air moves. Sailors once believed they were glimpsing ghost ships or distant islands that vanished when approached. In truth, they were seeing the atmosphere act like a giant uneven lens, bending light into scenes that look real but exist only in air and imagination. It's nature's most elegant deception, a painting made entirely of light, distance, and heat. Fact 31. How ocean waves form and travel. Stand on a beach and watch the ocean long enough and you'll see that the water never truly rests. Waves roll in one after another like the steady breathing of the sea, but what makes them move that way? Most ocean waves begin far out at sea when wind blows across the surface. As the wind transfers its energy to the water, ripples form, small at first, but growing as the wind continues. The stronger and longer the wind blows, the larger those ripples become. These waves can then travel vast distances across the ocean, carrying energy, not water itself, toward the shore. It's easy to think that the water in a wave moves forward, but in truth, Each water particle moves in a small circular motion. The energy passes from one particle to the next, like a silent message moving through the crowd. That's why, when waves reach shallow water near the coast, they start to slow down, grow taller, and finally break, releasing their energy in a rush of foam. Every wave that reaches the shore carries with it a story that began miles away. Where wind first brushed the open sea, the ocean may seem endless, but each ripple you see is a journey completed. Fact 32. The science of rogue waves. For centuries, sailors told stories of massive waves that appeared without warning, towering higher than anything around them, swallowing ships whole. Many dismissed those tales as exaggerations, until scientists finally confirmed they were true. Rogue waves are enormous, unpredictable walls of water that can reach heights of 30 meters or more. They don't come from storms or tsunamis, but from the ocean itself, a perfect collision of forces. When waves travelling in different directions meet, their energies can combine instead of cancelling out. In rare moments, this creates a single, giant wave far larger than the rest. What makes rogue waves especially dangerous is their suddenness. One moment the sea may seem calm, and the next a towering wave rises from nowhere. Modern radar and satellite data have captured them, proving they're real, and far more common than once believed. To sailors, rogue waves are a reminder that the sea can never be fully tamed. Even with all our science and technology, the ocean still keeps some of its strength hidden beneath the surface, waiting for the right moment to rise. Fact 33. The mysterious, bioluminescent beaches. Picture walking along a quiet beach at night, and with every step the sand glows blue beneath your feet. The waves sparkle like liquid stars lighting up the shoreline. It sounds like a dream, but it's real, thanks to a natural phenomenon called bioluminescence. Bioluminescence is the ability of certain living organisms to produce light. In the ocean, tiny plankton known as dinoflagellates release a soft blue glow when disturbed, by waves, by footsteps, or even by fish swimming through them. It's a chemical reaction between compounds in their cells that produces light without heat. These glowing waves can be seen in places like the Maldives, Puerto Rico, and parts of California, turning ordinary coastlines into glowing wonders. On dark nights, the effect can be breathtaking. The sea looks alive, every ripple a flicker of light. Scientists believe this glow may serve as a defense mechanism, startling predators or attracting larger ones to scare them off. Whatever its purpose, the result is pure beauty, the sea shimmering as if the stars themselves decided to come down and play in the surf. Fact 34. What causes whirlpools? Whirlpools have long stirred imaginations, swirling waters that seem to pull anything nearby into their spinning centre. In truth, they're not nearly as mysterious as they appear, but they are fascinating examples of fluid motion. A whirlpool forms when two opposing currents meet, or when water flows rapidly past an obstacle, such as rocks or narrow straits. The collision of these flows creates a spiral pattern, with water circling around a low-pressure centre. In mild cases, you'll see small whirlpools near riverbanks or behind boats. But in powerful tidal areas, such as Norway's Saltstraumen or Japan's Naruto Strait, whirlpools can grow massive and dangerous, with currents strong enough to pull in small vessels. These natural whirlpools are driven by enormous tidal movements, millions of gallons of water shifting direction every few hours. Though they look menacing, whirlpools are simply the ocean's way of balancing its energy, spinning off excess motion until it calms again, a reminder that even chaos has rhythm. Fact 35. The natural rhythm of tides. If the ocean had a heartbeat, it would be the rhythm of the tides, the gentle rise and fall of sea level that repeats every day without fail. Tides are caused by the gravitational pull of the moon and, to a lesser extent, the sun. As the moon's gravity pulls on Earth, it tugs at the oceans, creating a bulge of water on the side closest to it. A second bulge forms on the opposite side due to the centrifugal force of Earth's rotation. As Earth turns, these bulges move around the globe, causing high and low tides in a steady rhythm. Coastal communities have lived by this rhythm for centuries, fishing, sailing, and trading according to the moon's pull. The cycle repeats roughly every 12.5 hours, meaning 2 high tides and 2 low tides each day. Standing by the shore, you can almost feel it. the slow inhale and exhale of the planet. The tides remind us that even the sea, in all its vastness, still dances to the pull of something far away, a silent connection between Earth and Moon that never breaks. Fact 36. The physics of ice circles on frozen rivers. Imagine standing by a winter river and seeing a perfect circle of ice slowly spinning on the surface, not drifting away, not breaking apart, just silently rotating like a record. That's an ice circle, one of the strangest and most hypnotic natural formations you can witness. Ice circles usually appear in slow-moving sections of rivers or lakes where the current has a gentle rotation. As cold temperatures freeze the water, a piece of ice breaks away and starts to spin within the slow whirlpool. As it turns, friction with surrounding ice or slush gradually grinds its edges into a perfect circle. The rotation keeps it from freezing to the surface, allowing it to spin for hours, even days, until the current changes or the weather warms. Scientists have recreated the phenomenon in labs and found that the perfect roundness comes from steady motion combined with constant erosion by friction. So when you see one, it's not magic, it's mathematics and motion in harmony. A river, a chill, and a steady spin. Nature sketching geometry with water and ice. Fact 37. How icebergs carve from glaciers. The cracking sound of a glacier breaking apart is both thunderous and haunting, a reminder that even frozen giants are in constant motion. When a piece of a glacier breaks off and falls into the sea, the process is called calving. Glaciers are rivers of ice that flow slowly toward the ocean under their own immense weight. As they reach warmer coastal waters, the front of the glacier begins to melt and weaken. Cracks form, deepening over time until a massive slab finally breaks away, crashing into the sea to become an iceberg. The size of these icebergs can be astonishing. Some are as small as cars, others as large as skyscrapers, and as they drift, they melt gradually, releasing fresh water back into the ocean, part of the planet's endless water cycle. The sound of calving can echo for kilometers, like distant thunder rolling through a frozen canyon. It's dramatic, but it's also natural, a slow release of pressure that's been building for years, sometimes even centuries. Fact 38. The sound of singing sand dunes. It sounds impossible, a desert that sings, yet in certain parts of the world, sand dunes can produce deep humming notes that roll through the air like an organ's tone. This rare acoustic wonder is known as singing sand dunes or booming dunes. The sound happens when dry, well-sorted grains of sand, usually all about the same size, slide down the steep face of a dune. As they move, friction and vibration between the grains synchronize, creating a resonant frequency that can be heard for miles. Different dunes produce different tones, from low rumbles to clear, musical hums. Conditions must be perfect. The sand must be dry, the temperature right, and the grains smooth. Some deserts, like those in Morocco, Chile, and parts of China, are famous for their singing hills. The ancient travellers who heard these dunes thought the sound came from spirits or distant drums. But in truth, it's the voice of the desert itself, millions of grains moving together, creating a note that hums across the horizon. Fact 39. Why lakes can explode, Nyos and Kivu events. It sounds like science fiction, but some lakes can actually explode. In rare cases, gases trapped deep beneath their waters build up until a sudden release triggers a deadly eruption. The most infamous event happened in Lake Nyos, Cameroon, in 1986. The lake sits above a pocket of volcanic rock that leaks carbon dioxide into the water. Over time, the gas accumulates at the bottom under high pressure. When a landslide or disturbance suddenly releases it, the gas erupts upward, a limnic eruption. At Nyos, a huge bubble of CO2 burst from the depths, spreading across nearby valleys. The invisible cloud displaced oxygen, suffocating more than 700 people and countless animals. A similar risk exists at Lake Kivu in East Africa, though scientists now monitor it closely. In a controlled way, they even extract the gas for energy, reducing danger while turning risk into resource. These lakes remind us that calm waters can hide great forces, quiet on the surface but storing power below. Fact 40. The rare phenomenon of frozen bubbles in ice. Sometimes nature traps beauty in the most unexpected places, like the frozen lakes of winter, where bubbles of air seem suspended in crystal clear ice. These aren't ordinary air pockets, but frozen methane, the same gas that fuels stoves and lamps. Here's how it works. Organic matter like leaves or algae decays on the lake bed, releasing methane. As the gas rises, it gets trapped in layers of freezing water. Each new freeze captures another cluster of bubbles, creating towers of white circles stacked inside the ice. When the ice is clear and the sunlight hits just right, the effect is stunning. A three-dimensional display of bubbles frozen in time. It's breathtaking, but it also hints at a hidden danger. When the ice melts, that methane escapes into the atmosphere, adding to greenhouse gases. So those bubbles are both art and warning. Nature showing us beauty, while reminding us that every frozen lake has a story to tell about the life and energy beneath its surface. Fact 41. The creation of jet streams. High above us, in the upper layers of the atmosphere, invisible rivers of air race around the planet at speeds faster than a jet plane. These are the jet streams, powerful, narrow bands of wind that flow from west to east and shape much of Earth's weather. Jet streams form where warm and cold air masses meet. The contrast in temperature and pressure between these regions creates a steep gradient that accelerates air at high altitudes. The rotation of the Earth then bends these winds, guiding them into long, twisting paths that encircle the globe. There are several jet streams, the polar and subtropical jets being the most well-known. They act like steering currents, guiding storms and influencing flight paths. Pilots even use them to save fuel, riding their powerful tailwinds across continents. Though invisible, jet streams are among the most influential forces in the atmosphere, the unseen architects behind shifting weather patterns and the rhythm of the seasons. Fact 42. The role of trade winds in global climate. For centuries, sailors relied on them to cross the oceans, calling them the trade winds, steady, predictable breezes that blow from east to west near the equator. But beyond their usefulness to explorers, these winds play a vital role in shaping Earth's climate. Trade winds form as warm air rises near the equator, moves toward the poles, and then cools and sinks around 30 degrees latitude. This circulation pattern, known as the Hadley cell, drives a global loop of air movement. These winds push warm surface waters westward, helping to form tropical rain belts and powerful ocean currents, like the equatorial current and the Gulf Stream. When they weaken or reverse, global weather patterns shift, triggering events such as El Niño and La Niña. So while they once carried ships laden with spices and goods, today we understand the trade winds as vital cogs in the great atmospheric machine that regulates rainfall, ocean circulation, and temperature across the planet. Fact 43. What causes monsoons? Monsoons are more than just heavy seasonal rains. They are vast rhythmic shifts in wind and weather that affect billions of people each year. A monsoon begins with the temperature contrast between land and sea. During summer, land heats up faster than the ocean, causing air above it to rise. Moist ocean air rushes inland to replace it, bringing months of rainfall. In winter, the process reverses, the land cools more quickly, and dry winds blow back toward the ocean. This simple thermal cycle drives some of the most dramatic weather patterns on Earth, particularly in South and Southeast Asia. Monsoons fill rivers, nourish crops, and sustain entire civilizations. Yet when they come too early, too late, or too strong, they can also bring devastating floods. The monsoon is nature's great balancing act, an ancient pulse of wind and water that sustains life and reminds us of our deep connection to the rhythm of the planet. Fact 44. The science behind katabatic winds. In the world's coldest and most rugged places, a silent force can sweep down valleys with incredible power. These are katabatic winds, gravity-driven currents of cold, dense air that flow downhill from mountains or ice sheets. They form when air over high ground cools rapidly, becoming heavier than the air below. Gravity then pulls it downslope, sometimes accelerating to hurricane-like speeds. Antarctica is home to some of the strongest katabatic winds on Earth, where they can exceed 200 kilometers per hour. These winds shape the landscape, scouring ice, carving valleys, and influencing local climates. In Greenland, they even help push icebergs out to sea, though invisible. Katabatic winds remind us how temperature and gravity can combine to move vast masses of air, proof that even the coldest places on Earth are never truly still. Fact 45. Why the Chinook winds. Warm-up valleys. On the eastern side of the Rocky Mountains, a sudden gust can turn winter into spring in just a few hours. Locals call it the Chinook wind, or simply the snow eater. Here's how it happens. As moist air from the Pacific rises over the mountains, it cools and drops its moisture as rain or snow. When that same air descends on the other side, it compresses and warms rapidly, becoming dry and surprisingly mild. Temperatures can jump by 20 degrees Celsius in a single afternoon. Snow melts, rivers swell, and the landscape transforms almost instantly. The Chinook is a reminder of how air's journey, up, over, and down, can completely change its nature. It's not just a wind, it's a messenger of warmth, carrying the story of its mountain crossing and the physics of heat hidden in its breath. Fact 46. How the Mistral shapes Mediterranean weather. In southern France, there's a wind so fierce and legendary that it has shaped both the land and the people. It's called the Mistral, a cold, dry wind that rushes down the Rhone Valley and out into the Mediterranean Sea. The Mistral forms when high-pressure air over northern Europe meets low-pressure systems over the Mediterranean. This pressure difference channels cold air southward, funneled by the valley's shape, accelerating it like air through a tunnel. The result? Days of clear skies, sharp sunlight, and bone-chilling wind. Though it can feel harsh, the Mistral also brings life. It clears the air of humidity, helping vineyards and olive groves thrive. Painters like Van Gogh once described its clarity, the way it sharpens colours and makes the world look freshly washed. But it's unpredictable, sometimes arriving without warning, its howls echoing through the countryside. The Mistral is both sculptor and storyteller, a wind that defines the Mediterranean's rhythm and temperament. Fact 47. Dust storms and their long-distance travel picture a wall of dust stretching across the horizon, turning day into dusk. That's the power of a dust storm, a sweeping surge of wind that lifts tons of fine particles into the sky and carries them for thousands of kilometres. These storms usually start when strong winds blow over dry, loose soil. The smallest grains, lighter than sand, rise high into the atmosphere, sometimes travelling across oceans. Saharan dust, for instance, often crosses the Atlantic, feeding the soils of the Amazon rainforest. It's an incredible exchange. Deserts nourishing jungles, continents connected by air. But dust storms can also darken skies, damage crops, and affect air quality for millions. From Africa to Asia to the American plains, these storms are reminders of Earth's interwoven systems. Proof that even the finest grains of soil can shape the destiny of distant lands. Fact 48. How wind erosion sculpts landscapes. Wind doesn't just move air, it carves stone. Over centuries it has sculpted deserts into natural cathedrals and balanced rocks into impossible shapes. This slow artistry is called wind erosion. As sand grains are carried by the wind, they act like tiny chisels, wearing away at rock surfaces. The process is subtle, a whispering abrasion that, over millennia, forms arches, pillars, and dunes. Some of the most iconic desert landscapes, from the American Southwest to the Sahara, owe their beauty to this invisible sculptor. Wind erosion also shifts dunes, creating patterns that move like waves across the desert. Each gust adds or removes a layer, reshaping the terrain ever so slightly. It's a reminder that landscapes are never static. Even the mightiest cliffs are temporary, patiently sculpted by the breath of time. Fact 49. The phenomenon of sudden wind. Shear. Not all winds move smoothly. Sometimes the air changes direction or speed in an instant. A sharp shift, known as wind shear, is one of the most dangerous and least visible forces in the atmosphere. Wind shear can occur near thunderstorms, mountains, or jet streams. For pilots, it's a serious concern, especially during takeoff or landing, when a sudden loss of lift can occur. That's why airports now use advanced radar systems to detect it. But in nature, wind shear also plays a creative role. It helps form the rotation that can lead to tornadoes, or influence the structure of tropical storms. It's a paradox of nature. The same invisible twist of air that can endanger life also gives birth to some of the atmosphere's most breathtaking displays of power. Fact 50. The mysterious sounds produced by strong winds. Ever heard the eerie hum of wind through power lines or the mournful howl across a canyon? Strong winds often create sounds that seem alive, haunting, musical, or even whispering. These sounds are caused by air vibrating as it passes over objects, much like the reed of a musical instrument. Canyons, cliffs, and buildings can all amplify or shape these tones. In open spaces, the vibrations can blend into deep, ghostly wails that have inspired countless legends. In places like mountain passes or polar ice fields, explorers have reported singing winds that seem to come from nowhere. Scientists explain it as resonance, the same physics that makes a flute sing or a bottle hum. So next time you hear the wind moan outside your window, listen closely. You're hearing nature's music, a symphony conducted by pressure, vibration, and the endless motion of the air itself. Fact 51. Fire rainbows and circumhorizontal arcs. Despite their name, fire rainbows have nothing to do with fire, and they aren't rainbows in the usual sense either. These brilliant streaks of colour appear high in the sky, often beneath cirrus clouds, and they look like sunlight painted across a canvas of ice. A fire rainbow occurs when sunlight passes through ice crystals shaped like tiny plates, suspended horizontally in the upper atmosphere. When the sun is high enough, usually above 58 degrees, its light refracts through those crystals at just the right angle to create a horizontal band of shimmering colours. It's rare, fleeting, and breathtaking. People often mistake it for a rainbow or a halo, but its palette is softer and wider, more like an oil painting than an arc. The fire part? That's just our human way of naming something so dazzling. A sky that seems to burn with colour, even though it's made entirely of light and ice. Fact 52. The red tide phenomenon. Imagine standing by the sea, and instead of deep blue water, you see crimson waves rolling toward the shore. This strange event is called a red tide, though its colour can vary from rust to brown depending on the organisms behind it. Red tides occur when certain microscopic algae, especially dinoflagellates, multiply rapidly, tinting the water and sometimes releasing toxins. Warm temperatures, calm seas, and nutrient-rich waters can trigger these blooms. Not all red tides are harmful, but some can poison marine life, close fisheries, and cause respiratory irritation in coastal areas. The sight may be mesmerizing, but beneath that beauty lies a fragile balance, a reminder of how sensitive our oceans are to change. Even from space, satellites can spot these blooms, vast red swirls tracing the ocean's heartbeat, marking one of nature's most vivid warnings. Fact 53. The science of heat waves. A heat wave isn't just a few hot days. It's a prolonged stretch of extreme heat, where temperatures stay unusually high even at night. What makes heat waves fascinating is how they build and linger. They form when a high-pressure system settles over an area, trapping warm air like a lid. With little wind or cloud cover, the heat intensifies day after day. Cities suffer most because concrete absorbs and re-releases heat, creating what's known as the urban heat island effect. Heat waves can stretch human endurance and strain ecosystems. Rivers warm, crops wilt, and power grids falter as demand for cooling soars. Yet they also reveal how interconnected our weather truly is. One stagnant air mass can ripple across continents, reshaping climate patterns for weeks. It's one of the simplest yet most powerful forces in the atmosphere, the relentless stillness of trapped heat. Fact 54. When rivers flow, backward rivers seem timeless, always flowing downhill, always in one direction. But sometimes the unthinkable happens. They flow backward. This rare reversal usually occurs when powerful natural forces push against the normal current. Earthquakes, hurricanes, or sudden tidal surges can all force rivers to change direction temporarily. In 2011, for example, the Mississippi River reversed its flow during a massive storm surge. On a smaller scale, landslides and volcanic activity can also shift the ground, altering the gradient and sending water upstream. It's a reminder that gravity may rule, but nature occasionally bends the rules. For a moment, the river becomes a mirror of chaos, flowing against its own design, showing just how dynamic and unpredictable our planet can be. Fact 55. Blood rain and its true cause. Throughout history, people feared blood rain, crimson showers that seemed to fall from the heavens. Ancient witnesses thought it was an omen, a message from above, but science has revealed a far gentler truth. Blood rain occurs when fine red dust or spores mix with rainwater. Winds can carry this dust across great distances, often from deserts or dry regions, tinting the rain with rusty hues. When it falls, the droplets appear stained, leaving reddish streaks on windows, cars, or stone. In recent years, samples of blood rain from places like India and Europe have shown traces of sand and microorganisms, not anything mysterious. It's a beautiful illusion, proof that even something as ordinary as dust can turn rain into a spectacle, reminding us that the sky often borrows its colour from the earth itself. Fact 56. The strange. Raining fish. Phenomenon. It sounds like a tall tale. Fish falling from the sky. Yet this bizarre event has been documented around the world. The most famous place for it is Lloro, a small town in Honduras, where residents celebrate the annual Lluvia de Peces, or rain of fish. Scientists believe the mystery begins with powerful updrafts during storms or waterspouts over lakes and oceans. These swirling columns of air can lift lightweight fish, carrying them high into the clouds before dropping them miles away when the storm weakens. In other cases, floods sweep fish out of rivers and deposit them across fields once the water recedes, making it seem as if they fell from above. No matter the cause, the sight of fish littering the streets after rainfall is something that defies ordinary explanation, a whimsical reminder that weather still holds surprises we don't fully understand. Fact 57. The phenomenon of glowing seas. Imagine standing on a beach at night and watching waves crash in neon blue. That shimmering glow is called bioluminescence, light produced by living organisms. Tiny marine plankton called dinoflagellates are the main artists behind this glow. When disturbed by waves, footsteps, or even a boat's wake, they emit light through chemical reactions inside their cells, a kind of biological spark. The result is breathtaking: glowing tides, shining footprints, and even trails of light following swimming fish. Some species use the glow to confuse predators, while others use it to attract prey. Places like the Maldives, Puerto Rico, and parts of California are known for these magical displays. For a few nights each year, the sea transforms into a living light show, a soft blue reminder of the mysteries that stir beneath the waves. Fact 58. How nature creates methane. Explosions in tundras. In the frozen stretches of the Arctic tundra, something strange has been happening. Craters appearing out of nowhere as if the Earth itself had burped. The culprit, methane explosions. As permafrost, the frozen ground that covers much of the north, thaws due to warming temperatures, ancient organic material trapped for thousands of years begins to decompose. This releases methane, a gas that builds up under pressure beneath the surface. When that pressure becomes too great, the ground literally explodes, sending chunks of earth flying and leaving behind gaping craters. Scientists have discovered dozens of these in Siberia, some large enough to swallow small buildings. It's a dramatic reminder that the Arctic isn't as silent as it seems. Beneath its icy crust, chemical and geological forces are quietly reshaping the land. Fact 59. The phenomenon of ball ice on beaches. Along certain northern shores, winter brings an enchanting mystery. Round, smooth spheres of ice scattered across the beach like marbles left by giants. They're known as ball ice or ice eggs. These icy orbs form when small chunks of ice in the water are rolled by wind and waves, layering more ice onto their surfaces as they spin. Over time, they grow into perfect spheres, polished by the motion of the sea. Such scenes have been spotted in Finland, Russia, and Alaska. Beaches turned into surreal fields of icy pearls. The phenomenon is rare because it requires just the right mix of temperature, wind, and wave strength. For a few hours or days, nature becomes an artist, sculpting frozen perfection before it melts quietly back into the sea. Fact 60. Why deserts sometimes bloom. Overnight, deserts are known for their silence and dryness, endless sand and stone under an unforgiving sun. But every few years, when conditions align, something extraordinary happens. They burst into colour. This desert bloom begins when rare rainfall seeps into the soil, awakening seeds that have lain dormant for years. Within days, the barren ground transforms into a carpet of wildflowers, painting the landscape in purples, yellows, and pinks. In places like the Atacama Desert in Chile or California's Death Valley, these blooms are spectacular, short-lived miracles that can be seen from space. Once the heat returns, the flowers wither, and the desert returns to its quiet state. It's nature's proof of patience, that even the driest places on Earth hold life waiting silently for its moment to shine. Fact 61. Meteor showers and shooting stars. Few sights spark wonder like a night sky streaked with shooting stars. Meteor showers happen when Earth passes through a trail of dust and debris left behind by comets. These tiny particles, often no larger than grains of sand, burn brightly as they enter our atmosphere at incredible speeds, sometimes tens of kilometers per second. The friction between the meteoroid and the air produces the glowing streak we call a meteor. During peak showers like the Perseids or Geminids, dozens of these luminous trails can be seen every hour, creating a cosmic light show. While they're beautiful, these meteors are harmless for the most part, burning up completely before reaching the ground. Yet each one is a tiny visitor from the depths of space, a reminder of how alive and dynamic the universe above us truly is. Fact 62. What causes eclipses? An eclipse occurs when one celestial body blocks another, creating a dramatic play of light and shadow. A solar eclipse happens when the moon passes between the sun and Earth, casting a shadow on our planet. A lunar eclipse occurs when Earth passes between the sun and moon, causing the moon to glow reddish from sunlight filtered through our atmosphere. Eclipses can be total, partial, or annular, depending on how perfectly the bodies align. Ancient civilizations saw eclipses as omens, but today we understand them as predictable celestial mechanics. The next eclipse is always just a calculation away, and witnessing one, even partially, is a humbling reminder of the cosmic choreography that unfolds above us daily. Fact 63. The moon illusion. Have you ever noticed the moon looking enormous near the horizon, but much smaller high in the sky? This isn't about size changes. It's a trick of perception known as the moon illusion. When the moon is close to the horizon, our brain compares it with trees, buildings, or mountains, making it seem bigger than it really is. High overhead with no reference points, it looks much smaller, even though its actual size hasn't changed. This optical illusion has fascinated humans for millennia, inspiring myths and awe. The moon remains constant in reality, but our minds are quick to reinterpret the world around us, creating wonder from perspective alone. Fact 64. Solar pillars and sundogs. On cold mornings, you might notice bright spots or vertical shafts of light near the sun, called sundogs and solar pillars. They form when sunlight interacts with ice crystals suspended in the atmosphere, usually in cirrus or cirrostratus clouds. Sundogs appear as bright flares to the left and right of the sun, while pillars are vertical shafts above or below it, sometimes extending for miles across the sky. These phenomena are common in polar regions but can appear anywhere with cold, clear air. They're not rare miracles, just nature's light refracting and reflecting in the sky. Yet their beauty makes them seem like magic. Moments when the ordinary sun transforms into something extraordinary. Fact 65. Earthshine on the moon. Ever noticed a faint glow on the dark part of a crescent moon? That's called earthshine, sunlight reflected off Earth itself, illuminating the moon. Earthshine is brightest when our planet's oceans and clouds reflect sunlight directly onto the lunar surface, allowing us to see the dark part faintly glowing. This subtle illumination was first studied in the 16th century but continues to amaze observers today. It's a quiet reminder that Earth and Moon are intimately connected, a cosmic conversation of light that lets us see the Moon not just by its own reflection of the Sun, but through the glow of our home planet. Fact 66. Zodiacal light in the night sky. Before the darkness of night fully settles, a faint, triangular glow sometimes appears along the ecliptic, the path the sun follows across the sky. This is zodiacal light, caused by sunlight scattering off dust particles in the plane of our solar system. The dust comes from comets and asteroid collisions, drifting silently between the planets. Zodiacal light is best seen from dark locations, just after sunset or before sunrise, and appears as a soft, ethereal cone of light pointing upward. Though subtle, It's a reminder that the solar system is full of tiny travelers, and even the space between planets is alive with cosmic dust reflecting the sun's brilliance. Fact 67. How solar flares affect Earth. Solar flares are sudden bursts of energy from the sun's surface, releasing streams of electromagnetic radiation into space. When these powerful events are directed toward Earth, they interact with our magnetic field, producing dazzling auroras near the poles. But solar flares can do more than paint the sky. Intense flares can disrupt satellites, communications, GPS systems, and even power grids. Scientists monitor the sun constantly, using spacecraft to predict when flares might hit. The sun, though distant, has a direct and tangible effect on our planet, reminding us that our life on Earth is deeply linked to the activity of our star. Fact 68. The phenomenon of noctilucent clouds. High above Earth, in the mesosphere, are clouds that glow after the sun has set. Noctilucent clouds, meaning night shining. They appear as wispy electric blue streaks, visible only under very specific conditions during summer months at high latitudes. Formed from tiny ice crystals, these clouds catch sunlight long after the ground is in shadow, creating a mysterious glow against the darkening sky. Scientists believe that changes in atmospheric composition, including water vapor and dust particles, influence their formation. Noctilucent clouds are a subtle reminder that even at night, the sky can hold surprises that stretch our imagination and highlight the delicate layers of Earth's atmosphere. Fact 69. The mysterious sprites. Above thunderstorms. Above some thunderstorms, something truly otherworldly occurs. Glowing red shapes shoot upward from the storm tops. These are sprites, massive electrical discharges that leap high into the mesosphere. Sprites can take the form of jellyfish, carrots, or columns of light, often invisible to the naked eye unless conditions are just right. They are triggered by strong lightning strikes, yet they appear far above the storm, in a region where the air is extremely thin. For centuries they were unknown to humans, recorded only in rare photographs, until modern research confirmed their existence. Sprites reveal that thunderstorms have layers of power we can barely see, connecting Earth's surface with the high sky above. Fact 70. The rare event of lunar rainbows. While rainbows are commonly associated with the sun, the moon can create them too, lunar rainbows or moonbows. They occur when moonlight, usually during a full moon, refracts through water droplets in the atmosphere. Moonbows are faint, often appearing white to the human eye due to the low intensity of light, though cameras can reveal their colours. They are most visible in waterfalls, misty rain, or light rain under a clear night sky. Catching a lunar rainbow is rare, but it's a magical reminder that the moon's gentle glow can create beauty just like the sun, turning night into a canvas for fleeting, quiet spectacles. Fact 71. The synchronized glow of fireflies. On warm summer nights, forests and fields can come alive with tiny blinking lights. Fireflies don't glow randomly. Their flashing patterns are often synchronized, creating waves of light that seem choreographed across the landscape. This bioluminescent display is a form of communication, usually for mating. Males flash to attract females who respond with their own signals. In some species, hundreds or even thousands of fireflies coordinate their flashes, creating mesmerizing patterns that ripple across trees and grass. Scientists are still studying how fireflies synchronize so precisely, with some believing they respond to the flashes of their neighbors in a feedback loop. Watching them is like seeing nature's own light show, tiny lanterns performing an intricate dance across the night. Fact 72. How plants communicate through signals. Plants might seem quiet, but they have their own ways of sending messages. Through chemical signals, electrical impulses, and even vibrations, plants can warn each other about dangers like insects or harsh conditions. For example, when a leaf is attacked by pests, the plant releases chemicals into the air that neighbouring plants can detect. Those neighbours then activate their own defences, producing bitter compounds or protective resins. Some roots even send signals through the soil, alerting nearby plants underground. This hidden communication network shows that life on Earth is interconnected in ways we rarely notice. A silent, ongoing conversation happening all around us, beneath our eyes. Fact 73. the phenomenon of animal migration navigation. Every year, countless species embark on long migrations, some spanning thousands of kilometers. Birds, whales, butterflies, and even sea turtles navigate with astonishing precision, often returning to the same location year after year. Animals use multiple tools to guide them: the sun, stars, Earth's magnetic field, smell, and even polarized light patterns. Monarch butterflies, for instance, travel from Canada to central Mexico, guided by a combination of the sun and innate biological maps encoded in their genes. The accuracy of these journeys continues to fascinate scientists. Migration reminds us that even without technology, nature has evolved incredible systems for survival and orientation across vast distances. Fact 74. How bioluminescent fungi light up forests. Some of the darkest forests hide their own sources of light, glowing mushrooms known as bioluminescent fungi. These organisms emit a soft greenish glow, often visible on rotting wood or damp soil at night. The light is produced by a chemical reaction inside the fungus, using oxygen and a molecule called luciferin. Scientists believe the glow helps attract insects, which then spread spores and aid in reproduction. Walking through a forest lit by these tiny lanterns is like entering a natural fairy tale. It's a subtle reminder that even in darkness, life finds ways to shine and communicate. Fact 75. Why some deserts bloom. After decades, some deserts can appear lifeless for decades. Yet beneath the sand and gravel, seeds wait patiently for the right conditions. When rare rainfall comes, dormant seeds germinate almost simultaneously, creating a sudden explosion of colour across barren landscapes. This phenomenon, often called a desert bloom, transforms arid land into a vivid display of flowers. The Atacama Desert in Chile and the deserts of California have experienced these spectacular blooms, sometimes visible from satellites. It's a powerful demonstration of nature's resilience, life waiting silently for opportunity, and when the moment comes, exploding into brilliance that can last just days or weeks. Fact 76. The fairy circles of Namibia and Australia. Scattered across the arid landscapes of Namibia and parts of Australia, strange, perfectly round patches of bare soil appear amidst grasslands. These fairy circles have puzzled scientists and locals for centuries. Theories suggest they form due to competition for water. Grasses around the circle consume moisture more effectively, leaving the centre barren. Termites have also been proposed as architects, clearing vegetation to create their underground homes. The result is almost unnaturally precise, with circles often appearing in geometric patterns across the desert. Despite their eerie appearance, fairy circles are part of a balanced ecosystem, showing how subtle interactions between plants, soil, and animals can create patterns that look magical yet are deeply rooted in natural processes. Fact 77. Coral spawning. Synchronized by the moon. Coral reefs aren't just beautiful, they're punctual. Once a year, many species of coral release eggs and sperm into the water simultaneously, in an event called mass spawning. Remarkably, this synchrony is guided by the moon's cycles. As the full moon approaches, corals detect the subtle changes in moonlight, temperature, and tides. At a precise moment, countless corals across miles of reef release gametes together. This increases the chances of successful fertilization and overwhelms predators with sheer abundance. Watching a coral reef in the days after spawning is like seeing the ocean itself pulse with life, an intricate dance timed by lunar rhythm. Fact 78. How trees create their own weather trees are more than passive greenery. They actively influence local climates through transpiration. As water evaporates from leaves, it adds moisture to the air, cooling surroundings and sometimes even triggering rainfall. Forests can generate local winds, regulate humidity, and create microclimates suitable for diverse species. The Amazon, for instance, recycles vast amounts of water, influencing rainfall patterns not just locally but across South America. In essence, trees act like natural air conditioners and water distributors, shaping weather patterns while quietly supporting the ecosystems around them. Fact 79. The mysterious murmuration of starlings. As dusk falls, countless starlings take to the sky, moving as one fluid, twisting entity. This mesmerizing dance, called a murmuration, is more than a spectacle. It's a survival strategy. By flying in tightly coordinated flocks, birds can fuse predators, reduce individual risk, and communicate through collective movement. Scientists studying murmurations have found that each bird adjusts its speed and direction in response to just a few neighbours, creating an almost instant wave of motion across the flock. The sight of thousands of birds undulating in harmony is both beautiful and humbling, a natural reminder of the power of collaboration and instinct in the animal world. Fact 80. The phenomenon of red tides and algae. Bloom's red tides, caused by massive blooms of microscopic algae, are not only visually striking but ecologically significant. When conditions are right, warm water, calm seas, and nutrient abundance, these organisms multiply rapidly, turning ocean water crimson or rusty brown. Some algae produce toxins affecting marine life and humans alike. Fish may die, shellfish become unsafe to eat, and even coastal air can carry irritants. Yet red tides are also natural cycles, often providing food for certain species and showing the delicate balance of marine ecosystems. They serve as vivid reminders that even the smallest organisms can alter the colour and chemistry of entire seas, creating beauty, danger, and wonder all at once. Fact 81. The formation of stalactites and stalagmites. Step into a cave, and you might notice thin icicle-like formations hanging from the ceiling or rising from the floor. These are stalactites and stalagmites, shaped over thousands of years by dripping water saturated with minerals. As water seeps through limestone, and it carries dissolved calcium carbonate. When a drop falls from the ceiling, some of the mineral is left behind, slowly building a stalactite. When the same drop hits the ground, it deposits more minerals, gradually forming a stalagmite. Over centuries, some even meet to form columns, linking floor to ceiling. These formations remind us that time and patience can shape solid stone, turning simple water droplets into delicate architectural wonders. Fact 82. The process of fossilization. Fossils are nature's time capsules, preserving traces of life from millions of years ago. Fossilization occurs when organisms are buried rapidly under sediment. Over time, minerals replace organic material, leaving behind a rock-like replica of the original structure. Conditions must be just right. Oxygen levels low enough to slow decay, pressure from layers of sediment and mineral-rich water percolating through the remains. Fossils can capture bones, shells, or even imprints of leaves and skin, offering a glimpse into ecosystems long vanished. Fossilization is a quiet miracle, the way nature preserves the story of life for scientists and explorers to uncover eons later. Fact 83. The creation of natural glass. Like obsidian, volcanic eruptions produce many spectacular features, and among them is obsidian, a natural glass formed when molten lava cools rapidly. Unlike typical rocks that crystallize slowly, lava that solidifies too fast for crystals to form becomes smooth, shiny, and glass-like. Obsidian has fascinated humans for millennia, used for cutting tools, ornaments, and even mirrors. Its sharp edges made it a preferred material in ancient weaponry. From molten chaos to gleaming stone, obsidian shows how extreme heat and sudden cooling can transform magma into a material that's both beautiful and functional. Fact 84. The phenomenon of moving rocks in Death Valley. In California's Death Valley, large stones seem to move on their own across flat desert surfaces, leaving trails etched in sand and clay. Known as sailing stones, their motion puzzled scientists for decades. Recent research shows that a combination of ice, wind, and wet clay allows the rocks to slide slowly. During cold nights, thin sheets of ice form beneath the stones. When the sun warms the ice, it fractures into panels that float the rocks just enough for wind to nudge them along. The tracks left behind are almost like natural signatures, mapping the silent, patient movement of Earth's forces in one of its harshest environments. Fact 85. How mud volcanoes erupt without magma. Not all volcanoes spew lava. Mud volcanoes release water, gas, and mud instead of molten rock. They form where underground deposits of water and gas are trapped beneath layers of sediment. Pressure builds until the mixture forces its way to the surface, erupting in thick, bubbling flows. Some mud volcanoes can even create cone-shaped mounds that resemble traditional volcanoes. These eruptions, though cooler, demonstrate that geological activity isn't limited to fire and magma. The Earth can express its energy through pressure, water, and sediment, creating landscapes both strange and fascinating. Fact 86. The strange colour-changing rivers. Some rivers seem to defy reality, changing colour dramatically depending on season, mineral content, or microbial activity. For example, Colombia's Caño Cristales displays vibrant reds, yellows, and blues, earning it the nickname River of Five Colours. The hues come from aquatic plants and algae that thrive in clean, shallow water, combined with sunlight and mineral-rich rocks. Other rivers change colours due to suspended sediments or dissolved metals, creating emerald greens, deep blues, or rusty reds. Witnessing such a transformation is like seeing the river paint itself daily, a living artwork that reminds us nature constantly shifts its palette. Fact 87. Natural asphalt lakes, like La Brea. In places like Venezuela and California, lakes of natural asphalt or tar bubble at the surface, creating sticky black pools. These asphalt lakes form when oil seeps from underground reservoirs and reaches the surface, evaporating lighter hydrocarbons and leaving behind thick tar. Throughout history, humans have used asphalt for waterproofing, paving roads, and construction. Yet these lakes are also ecological traps. Animals sometimes get stuck, preserving fossils that later tell the story of extinct species. They are living reminders of Earth's hidden energy and how geologic processes slowly transform the land over millennia. Fact 88. The mystery of the singing stones. Scattered in deserts or volcanic plains, some stones seem to hum, whistle, or even produce musical tones when struck, moved, or rubbed. Known as singing stones or ringing rocks, their sound comes from the way stress is trapped inside the rock's crystalline structure. Factors such as mineral composition, shape, and even temperature contribute to the tone produced. Ancient cultures sometimes used these stones for ceremonies, drawn to their eerie yet melodic qualities. The idea that stone itself can sing is a reminder that the earth can produce sound in unexpected, almost magical ways. Fact 89. The spontaneous combustion of coal seams. Some coal seams buried underground can ignite without any spark from the surface. Heat from decomposition or chemical reactions inside the coal can build up over time, eventually causing a slow, smouldering fire. These underground fires can burn for decades, sometimes spreading over large areas. Famous examples include the coal fires of Centralia, Pennsylvania, and the Burning Mountain in Australia. Though dangerous, these fires reveal the intense energy stored within Earth's resources and how nature can release it quietly yet persistently over time. Fact 90. The blue lava of Indonesia's volcanoes. On the slopes of Indonesia's Kawah Ijen volcano, lava seems to glow an eerie blue at night. The effect isn't due to molten rock itself, which is bright orange, but to burning sulfur gases. When sulfuric gases emerge from the volcano and ignite in contact with air, they burn with an intense blue flame. As these flames flow down the crater walls, they can appear like rivers of liquid light, creating a surreal spectacle. This phenomenon shows that volcanic landscapes have surprises beyond molten rock, with chemical reactions painting the night in colours that feel almost otherworldly. Fact 91. The ozone hole and how it heals. The ozone layer is Earth's protective shield against harmful ultraviolet rays. In the late 20th century, scientists discovered a thinning over Antarctica, famously called the ozone hole. It formed due to chemicals like CFCs breaking down ozone molecules in the stratosphere. Thanks to global agreements like the Montreal Protocol, the use of these chemicals has drastically decreased. Over time, the ozone layer has begun a slow recovery, showing that international cooperation can have measurable effects on planetary health. The healing of the ozone hole is a reminder that even global-scale environmental problems can improve when action is taken. Fact 92. El Niño and La Niña. Cycles. El Niño and La Niña are climate patterns caused by changes in ocean temperatures in the Pacific. El Niño warms the surface waters, disrupting weather globally, often causing heavy rains in some regions and droughts in others. La Niña, on the other hand, cools the surface, often reversing these effects. These cycles influence hurricanes, monsoons, and even global temperatures, highlighting the intricate connection between oceans and atmosphere. Predicting their occurrence is crucial for agriculture, disaster planning, and water management around the world. They demonstrate that subtle shifts in ocean temperature can ripple across the entire planet, affecting life far from the Pacific. Fact 93. The role of the Coriolis effect in global winds. The Coriolis effect is caused by Earth's rotation and explains why winds and currents curve rather than travel in straight lines. In the northern hemisphere, moving air curves to the right. In the southern hemisphere, it curves to the left. This effect shapes major wind patterns, ocean currents, and even storm systems like hurricanes and cyclones. Without the Coriolis effect, weather systems would behave very differently, and the distribution of heat and moisture across the planet would be less organized. It's a subtle yet powerful reminder that Earth's rotation plays a vital role in the dynamics of our atmosphere. Fact 94. Why the northern and southern hemispheres have opposite seasons. When it's summer in the northern hemisphere, it's winter in the southern hemisphere, and vice versa. This is due to Earth's tilt of approximately 23.5 degrees relative to its orbit around the Sun. The tilt determines the angle and duration of sunlight hitting each hemisphere. During the northern hemisphere's summer, the North Pole tilts toward the Sun, receiving more direct sunlight, while the South Pole tilts away, receiving less. 6 months later, the situation reverses. This simple tilt explains the cyclical rhythm of seasons, driving ecosystems, agriculture, and human activities worldwide. Fact 95. The Great Pacific Garbage Patch. Circulation pattern. The Great Pacific Garbage Patch is a vast area in the North Pacific Ocean where debris, mainly plastics, accumulates. Ocean currents, specifically the North Pacific Gyre, trap floating materials in a slow-moving loop, concentrating waste over time. While the patch doesn't form a solid island, it's an enormous and concerning example of how human activity interacts with natural circulation. Winds, currents, and waves keep debris suspended, affecting marine life and ecosystems. The patch reminds us that our oceans are interconnected systems where human actions can have widespread, lasting consequences. Fact 96. The changing magnetic poles. Earth's magnetic poles are not fixed. They drift over time due to movements in the planet's molten outer core. The North Magnetic Pole, for instance, has been moving northward at several kilometers per year. These shifts can affect navigation systems, migratory species, and even satellites, though modern technology can adjust for changes. Over geological timescales, the poles have even reversed, flipping north and south completely, a process called a geomagnetic reversal. The drifting of magnetic poles reminds us that Earth is a dynamic planet, with forces beneath the surface continuously shaping its environment. Fact 97. Atmospheric rivers. Transporting moisture. Atmospheric rivers are narrow bands of concentrated water vapor moving through the sky, sometimes carrying more moisture than the Amazon River does on the ground. When they reach land, they can release intense rainfall, fueling floods or replenishing water supplies. These moisture highways are critical for ecosystems and human water resources, especially in regions like California and Western Europe. Though mostly invisible to the naked eye, satellites track them to predict storms and manage water resources effectively. Atmospheric rivers show that much of Earth's weather is a global conveyor belt, moving water thousands of kilometers through the atmosphere. Fact 98. The Earth's resonance, or hum. Earth itself vibrates, continuously, subtly, and silently. Known as the Earth's hum, these low-frequency vibrations are caused by interactions between the atmosphere, oceans, and solid Earth. Seismometers can detect this hum, which never stops, even in the absence of earthquakes. While imperceptible to human ears, it reveals that the planet is alive with movement on a scale we rarely notice. The Earth's hum reminds us that our planet is not static. It's a constantly resonating system, quietly vibrating beneath our feet. Fact 99. The phenomenon of permafrost. Thawing. Permafrost, ground that remains frozen for years, is now thawing in many regions due to rising temperatures. This releases trapped gases like methane and carbon dioxide, contributing further to climate change. Thawing permafrost also destabilizes landscapes, causing landslides, sinkholes, and damage to infrastructure in Arctic communities. Studying permafrost thaw helps scientists understand past climates and predict future environmental impacts. It's a stark illustration of how even frozen parts of Earth are dynamic, interacting with climate and ecosystems in ways that can have global consequences. Fact 100. The shifting of Earth's axis. Over time, Earth doesn't spin perfectly upright. Its axis wobbles slowly in a phenomenon called axial precession. This wobble alters the orientation of the poles over thousands of years, changing the timing of seasons and the position of stars in the sky. Combined with other cycles, this shift influences long-term climate patterns such as ice ages and warm periods. While imperceptible on a human timescale, it has been a silent architect of Earth's climate and astronomical history for millennia. The shifting axis reminds us that our planet is in constant motion, with subtle forces shaping life and landscapes across ages.